I've waited years.
How many years?
By now it must be.
It's 23 years, 4 months, 8 days.
One hour equals 7 years. Can you imagine that? Just a blink of an eye and you've already missed several days. What makes this movie so amazing is that it gets us to think about the idea that time itself is relative. It can move faster, slower, forward, backward, or even collapse.
Time's gonna change for me.
You once told me that when you came back we might be the same age.
Here's the coolest part. Every phenomenon we see in Interstellar can actually be explained scientifically. There's even a book called The Science of Interstellar, written by none other than Nobel Prize-winning physicist Kip Thorne, who was directly involved in the making of the film. Kip Thorne, a professor of physics at the California Institute of Technology and a close friend of Stephen Hawking, yes, that Stephen Hawking, the genius often compared to Einstein, whose life was also turned into a film. Together, Kip Thorne and director Christopher Nolan, famous for his idealism and precision, collaborated to make a movie that is not only genius in storytelling, but also scientifically accurate. How accurate? Let's break it down.
The planet is much closer to Gargantua than we thought.
Gargantua.
It's what we're calling them, the black hole. Miller's and Dr. Mann's planets both orbit it.
In Interstellar, we see a black hole named Gargantua. What's unique is that no one had ever visualized a black hole like this before. Why? Because this image wasn't imagined or taken from a textbook. It came directly from equations. These were Einstein's equations of gravity, rewritten by Kip Thorne to see what a black hole should actually look like. He and his team ran computer simulations, and what they produced became the breathtaking image of Gargantua that we saw on screen.
Oliver used equations that I gave to him, fed to him, to compute what this would look like if you're looking at this black hole in front of a large number of stars.
No one had ever done this before. Kip Thorne was the first person in history to visualize a black hole using Einstein's actual equations, and for the very first time, it was shown in Interstellar. That means when you watched the movie, you were witnessing the most realistic depiction of a black hole ever created. And if you're curious, you can even download the scientific journal where this simulation is explained in detail.
If it didn't look like something that would be comprehensible to the audience, we would have to manipulate it in some way. But what we found was, as long as we didn't change the point of view too much of the camera position, we could get some very understandable, tactile imagery from those equations. They were constantly surprising. Spoke to the maxim that, truth can be stranger than fiction.
This is why Interstellar became so famous, studied everywhere, and even used as a reference by scientists.
Interstellar is the year's biggest movie, partly because of the solid science behind the science fiction.
Interstellar is having an impact here on Earth. It's being called one of the most realistic science fiction films ever.
And this is where we get an image that looks something like the interstellar black hole.
But how does a black hole bend time so that 1 hour equals 7 years? Let me explain. There are two key terms often mentioned in the film: gravity and relativity.
It's not a ghost. It's gravity.
The only thing that can move across dimensions like time is gravity.
7 years back on Earth. That's relativity, folks.
Both come from Einstein's theory of general relativity, a theory that changed our understanding of space and time forever. Imagine space-time as a giant trampoline. If you place a heavy ball in the center, smaller balls rolling nearby will curve around it, as if they're being pulled in. This is how Einstein described gravity, and it explains why planets orbit the sun, and why this applies to the entire universe, including us. Now, what does this have to do with time? Because time cannot be separated from space. That's why we call it space-time. Like that trampoline sheet, time itself can be stretched and bent by massive objects.
So the fact that time moves differently here on the surface of the Earth than in a satellite orbit is very, very important to getting the GPS to work correctly.
On Earth, we don't really feel this because our gravity is too small to make a noticeable difference. But near a black hole, things are completely different.
Near a black hole, time's gonna change for me.
The gravitational pull of the black hole, if you're at some fixed distance away from it, is the same as the gravitational pull of 3 suns.
A black hole is an object with a mass millions of times greater than the sun. Its gravity is so extreme, it pulls in everything around it, even light. That's why it's called a black hole. Just like the trampoline analogy, a black hole bends space and time to such an extreme degree that time slows down dramatically.
That is precisely a precise analog of a black hole. All I do is change the labels.
As shown in the movie, 1 hour near its edge could equal 7 years back on Earth. And that's only at the edge.
Gravity on that planet will slow our clock compared to Earth's drastically.
I bet.
Well, every hour we spend on that planet will be 7 years back on Earth.
Imagine what happens if you go deeper. Scientists even debate what might happen if someone falls into a black hole. Would they die instantly, or discover secrets of the universe we can't even imagine?
After the horizon is a complete mystery. So, what's to say there isn't some way that the probe can glimpse the singularity and relay the quantum data?
This is exactly what Interstellar tries to explore. Cooper sacrifices himself, falling into the black hole to save Amelia. Inside, he finds himself in a 5-dimensional space. Why was it shown this way? And how was Cooper able to communicate with his daughter on Earth back when she was still a child?